Okay, so I was in the middle of number 12 here talking about Chebyshev's rule and empirical rule when I ran out of time, and the recorder stopped after I had talked about our data not meeting the empirical rule. So let's go to Chebyshev's rule. So I'm going to go back to the information that we had earlier, and I've sorted this data so it makes it easier. And if you don't know how to sort the data, all we need to do to sort our data is go to here it is, sort, and click on sort, and you tell it the column, the values, and smallest to largest, and hit OK, and it's going to sort them for you as it did for me here. And that's going to make our question a little bit easier to answer. All right, now Chebyshev's rule says at least, not approximately, but at least 75% of the data falls within 2 standard deviation. Now, we certainly have at least 75% of the data falling within 2 standard deviations because we had 85% of it within 1 standard deviation of the mean. So we know that that first condition is already met. But if we go ahead and do 2 standard deviations from the mean, in other words, if we take 154.35 minus 2 times our standard deviation, 28.885, we get 96.58. And if we take 154.35 plus 2 times our standard deviation, 28.885, we get 212.12. All right, and then if we count the numbers that fall between these, we'll notice that everything falls between them except the 250. So 19 out of the 20 pieces of data are within that interval, or 95% of the data is within that interval. So certainly, that is at least 75% falling within 2 standard deviations. Now, if we go to 3 standard deviations, this is going to get smaller, and this is going to go up to, 240 something, and we'll still be at 95%. Now, it says, Chebyshev's rule says that at least 89% is within 3 standard deviations. Well, we don't have to even do that computation because we're already at 95% of the data when we just do within 2 standard deviations of the mean. So this does satisfy Chebyshev's rule. And we're going to find that Chebyshev's rule is not the restrictive one, the empirical rule is. And we need to have that bell-shaped curve or something very close to a bell-shaped curve for something to satisfy that empirical rule. Whereas Chebyshev's rule tends to pertain to all data. All right, now let's go to our next one here. We're going to stay with our same set of data. But for number 13, we want to find the range in the 5-number summary, and then we'll draw a box plot as well as I can on this computer. All right, so let's find the range. And recall that the range is always our largest value minus our smallest value. So our largest value was 250, and our smallest value was 120. That gives us a range of 130. All right, now, our 5-number summary is composed of the minimum, the first quartile, the median, the third quartile, and the maximum. So let's start with our minimum value up here was 120. That's easy. Our maximum value, let's go ahead and get to, that was 250. All right, now I'm going to go to the median next. Now, the median, recall, if we have an even number of data, we need to average together the 2 middle pieces of data. So if we look here, the 2 middle pieces of data are right here and right here. Notice there's 9 pieces of data below this one, and if I go there, there's 9 pieces of data below this. So we need to average together 144 and 149. And we get 146.5. All right, now, let's sort of think of that 146.5 as being right here in between these 2 values. So now we're looking at the 10 pieces of data that are underneath or that are lower than 146.5. And to find the first quartile, we want the median of those 10 pieces of data. Well, if we look, the median is going to fall between 139 and 140. Again, we average those together, so our first quartile is 139.5. All right, now again, let's think of that original median as being right here. The 146.5 is right here. There are 10 pieces of data beneath it, so we want to find the median of those 10 pieces of data, and that will be our third quartile. So if we look down here, the 2 pieces of data in positions 15 and 16 are in the middle of those 2 pieces. So if we average together 160 and 163, we will get 161.5. And there is our 5-number summary. Now using that, we're going to draw a box plot. And I'm going to do my best with the paint function here on the computer. Let me pull it up. Now, when doing a box plot, the first thing that we need is a scale, and I'm not going to be very straight drawn on here. I'll do my best. Well, see, I was good there for a second or two. All right, and I want to scale this thing. Now, it starts at 120 and it goes to 250, so probably going to, I'm going to say that's 120, and we're going up by 10. 130, 140, 150, 60. 70, 80, and we want them nice and dispersed as evenly as possible. 200, 210, 220, 230, 240. That wasn't very good, but and 250. All right, and I can probably erase that little piece over there just so I don't have it confusing us. So there's the end of my scale. Now normally, if I weren't drawing on my computer, I would label each of these as 130, 140, 150, 160. But because my numbers are going to get so crammed together and it's going to be hard for me to label them, I will label 250 down at this end. All right, so let's look back for a minute. Our minimum, we recall, was at 120, so I'm going to go ahead and make a little slash mark there. And our maximum was at 250. All right, now, if we look back, my median is 146.5. So let's see, 30, 40, 50. So 146 is in here somewhere. And I'm just having to kind of eyeball on here. All right. And then my first quartile was at 139.5. All right. So this was 130. This was 140. So somewhere in here. And then our third quartile was at 161.5. All right. So this was 130, 140, 150, 160. 161 is right in here. All right, so I make a box of my quartiles and my median. And then my whiskers go out to my minimum and my maximum. And of course we can see that there's a lot of variation going on between that third quartile and that 250. That 250 is way out there in comparison to the rest of the data. So that gives us a good idea of our spread. There's a lot more spread between data here. And there's also a lot of spread between the median and the third quartile that there isn't necessarily between the first quartile and the median. Okay, so there's that box plot. All right, so let's go back and see if I'm not running out of time, and I think I'm still good on time. Our last question. All right, so a team of basketball players has heights that are normally distributed with an average height of 78.9 inches and a standard deviation of 2.4 inches. Tom is a member of the team and measures 72.3 inches. We want to find the z-score for Tom and explain what it means. Now let's remember our z-score refers to our standard normal distribution. All right, so we're going to take the value of Tom's height, which was in this case 72.3. That goes on top of our fraction, and we want to subtract off our mean, 78.9. All of that's on top of the fraction for our z-score, and we divide by our standard deviation of 2.4. All right, so let's do that computation. Did I do that? Oh, I didn't. Okay, thought I'd messed up and hit the wrong thing. Okay, so we have 72.3 minus 78.9. That gives us negative 6.6, and divide by our 2.4, and that gives us negative 2.75. All right, now remember, since this is a standard normal distribution, or what we've just done is a standard normal distribution, this is normally distributed, and the empirical rule applies. All right, so remember that this is the number of standard deviations that Tom is away from the mean. He is 2.75 standard deviations below the mean. So Tom is 2.75 standard deviations below the mean. Now, 95% of people are going to be within 2 standard deviations of the mean, approximately 95% of people. So Tom is almost 3 standard deviations away from the mean, which means that's kind of a rare case. Tom is sort of short for this group of basketball players. So Tom is a lot shorter than the other players. That's what that z-score of negative 2.75 is telling us.